Good morning everyone. Myself, I am Kiranmai, working as Assistant Professor in B.V. Raju Institute of Technology in the Data Science Department. Today I am going to be discussing about asynchronous data transfer from computer organization subject. Let us go with the topic. When we go with the asynchronous data transfer, we can say like all operations inside the computer, they are going to be done with the help of clock pulses which were generated by the common clock pulses. And when we say like different data transfers are going to happen, here the registers which are present inside the interface and the registers which are present inside the CPU, if they share the common clock pulses, then we say like it is synchronous data transfer. Why? Because the registers inside the interface and registers inside the CPU, they are going to be sharing the common clock pulses which were generated by common clock generated. And we have another type of data transfer which we will be saying it as an asynchronous data transfer. In the asynchronous data transfer, the interface and the CPU, they will have their own private clocks, and those own private clocks, they will be generating their own clock pulses. So here we are going to be saying like it is an asynchronous data transfer. But here this interface and the CPU, they need to know when the data is coming from one unit to the another unit. So here we are going to be discussing about how exactly the asynchronous data transfer happens here. And here when we say like asynchronous data transfer, here we are going to be discussing it in two things. Like we will be saying like strobe pulses we will be using and handshaking pulses we will be using. The unit which is going to be sending the data, we are going to be terming it as an source unit. And the unit which is going to be receiving the data, we are going to be saying it as an destination unit there. Data transfer is going to be happening from source to the destination. And here we are going to be saying like how exactly the data transfer happens from source unit to the destination unit in asynchronous mode, when each unit have their own clock generators which will be generating the clock pulses. And as I have told, here we are going to be using strobe pulses and handshaking pulses. When we exactly go with the strobe pulse, it is the control signal which will be issued by any one of the unit. It may be source or it may be the destination. And this particular strobe pulse, it is going to be indicating like when the transfer has to occur. And when we go with the handshaking process, here we are going to be saying data transfers from source to the destination. And here we are going to be saying like the destination unit will be sending the acknowledgement like it had received the data to the source unit. Like acknowledgement, in the strobe clock pulse, in the strobe pulse, we are going to be saying like there will be no acknowledgement. The destination will not send any kind of acknowledgement like it had received the data. But in the handshaking, here the destination unit will be sending the acknowledgement to the source like it had received the data. And when we go with the strobe and the clock and the handshaking pulses, here we are going to be saying like strobe, it is like two kinds again. Like one will be source initiated strobe and another one will be the destination initiated strobe. In the same way, when we go with the handshaking also, we are going to study about source initiated handshaking and destination initiated handshaking. Let us go with the, like how exactly we are going to have like strobe initiated and destination initiated one. As you can see, like when we go with the strobe control, it is like one of the asynchronous data transfer, and it is going to be saying like when the transfer has to occur. And here if you see the diagram, you can see, as I have said, we are going to have the source unit and we are going to have the destination unit. And here you can see like we are going to have the data bus through which the particular data is going to, binary information is going to be transmitted, and we have the strobe control line which is going to be indicating like the valid data is present over the data lines. So when we first go with the first method, that is nothing but source initiated strobe, you can see the diagram, block diagram, where you can see like source unit is going to be like placing the valid data over the data bus, and source unit initiates the strobe pulse, like informing the destination unit like I am sending valid data to the data bus. And after that the both source and the destination will remain in high state for some time, so that the destination unit accepts the data. Then what the source unit will do is nothing but it will disable the strobe pulse, and then it will invalidate the data which is placed over the data bus. So here we can mainly specify in 4 steps. That is nothing but the first step is source placing the valid data over the data bus. The second step is like source initiating the strobe pulse, and then both remain in high state for some time, so the destination unit accepts the data, and source is going to be disabling the strobe line, and source invalidate, fourth one is invalidates the data on the data bus. And when we go with the timing diagram, you can see like how exactly the steps are going on. Like the first thing is like you can see the data is going to be the valid data which is placed over the data bus. It is represented through the rising edge here of the pulse, and after that it is going to be enabling the strobe pulse, which you are going to be seeing through the raising edge of the strobe pulse, and both remain in the high state for some time. So the data destination unit accepts the data. After that the source unit disables the strobe. Disables the strobe is specified by the falling edge of the timing signal, and next the source invalidates the data which is placed over the data lines. That is also shown through the falling edge of the pulse there. Okay, this is about the source initiated handshaking, where source is going to be saying to the destination like it had placed valid data over the data lines. Now we will see the second method of the strobe, that is nothing but destination initiated handshaking. When we see like destination initiated handshaking, you can see like the first thing is nothing but here destination unit enables the strobe pulse. Destination unit is saying like I am ready to accept the data, so the destination unit enables the strobe line. Then source is going to be placed. The second step is source places the valid data over the data bus, and both is going to be remaining in the high state for some time. After that the destination unit, as it had enabled the strobe pulse, the third operation which is going to happen here is nothing but destination unit disables the strobe pulse there, and the fourth operation is the source removes valid data over the data bus. So here as we are going to be specifically saying it as destination initiated strobe for the data transfer, we are going to be saying like strobe is going to be sending the strobe pulse, source is going to be placing valid data, then destination unit disables the strobe, and source removes the valid data from the data bus. And when we go with the timing diagram, you can see the first step what is going to happen here is nothing but destination enabling the strobe pulse, which we are going to be showing through the raising edge of the strobe pulse. and then source keeps the valid data over the data bus, which we are going to be showing through the raising edge of the data, and both remains in high state for the meantime, so the destination accepts the data. After that, the destination unit removes the strobe pulse, so we are going to be saying like it is represented through the falling edge of the clock pulse there, and then source is going to be removing the valid data from the data bus, which we are going to be showing through the falling edge of the data line there. Okay, this is how like destination initiated strobe for data transfer is going to happen. And let us go with the handshaking. In handshaking also we are going to have like source initiated handshaking and the destination initiated handshaking. As we already know, like in the strobe method, we don't receive any acknowledgement from the destination. But in the handshaking, we are going to be receiving the acknowledgement from the destination unit. And here we have something called data valid line, which is generated by the source unit, and data accepted line, which is generated by the destination unit there. And when we go with the source initiated handshaking process, you can see the diagram like this, where we have our source unit, where we have our destination unit there. And how exactly the data transfer is going to be happening here, you can see like you have the block diagram, you have the timing diagram that is going to be representing the different events timing there, and a sequence of events, the flow of events which are happening at the source initiated handshaking day. And how exactly the procedure happens is nothing but source first places valid data over the data bus, and then source is going to be enabling the data valid line. Why? Because it is going to be saying the destination like valid data is placed over the data lines. Then and it will wait for some time so that the destination unit accepts the data into its registers. After destination unit accepting its data, destination unit will enable the data accepted line. After source receiving the data accepted line enabled by the destination, source will invalidate the data, invalidate the the data valid line, we are going to say, like disabling the data valid line. After that, it will invalidate the data which is placed over the data bus. And then finally, as data accepted line is enabled by the destination unit only disables the data accepted line, so that again both the units will be ready for accepting, sending and accepting the next data there. So here you can see in the block diagram the representation, and when you go with the timing diagram, you can see first the source placing the valid data over the data lines, and you can see the arrow coming down, which is going to be representing like the source unit is going to be enabling the data valid line, and both remains in high state for a meantime. After that, the destination, you can see the arrow coming down, which specifies destination unit enabling the data accepted line. After that, you can see like the destination unit, it is going, this particular source unit, it is going to be disabling the data valid line, which you can see by this curve, and after that it will invalidate the data which is placed over the data bus, and finally the destination unit disables the data accepted line, where you can see it through this respective arrow there. And when we go with the sequence of events, as sequence of events, the process which is going to be happening there specified by the sequence diagram, we are going to be saying like source unit, what are the actions which were carried out at the destination unit, what are the actions which were carried out. And when we go with the source unit, you can see like the first operation which is happened is nothing but placing data on the data bus and then enabling the data valid line. After that, the destination unit will accept the data from the bus and it will enable the data accepted line. After enabling the data accepted line, the source is going to be disabling the data valid line and it is going to be invalidating the data which is placed on the bus. Finally, the destination unit disables the data accepted so that the destination unit is ready to accept the next data there. This is about the source initiated transfer. And let us now go with the destination initiated handshaking. How exactly it happens? As it is destination initiated handshaking, here the destination unit is going to be using an control signal called ready for data. So you can see the first thing what is going to happen is nothing but the destination unit will enable the ready for data line. It will enable the ready for data line. When it is reached by the source unit places valid data over the data bus and source unit it will enable the data valid line. And the destination unit accepts the data into its registers. After that, it will, as it had successfully accepted the data into the registers, the destination unit will disable the ready for data. After destination unit disables the ready for data, source unit, it will disable the data valid line and it will remove the valid data from the data bus. The process is going to be happening like this for the destination initiated handshaking. And when you see the timing diagram, you can see the destination unit, first it is going to be enabling the ready for data from where the source unit is going to be keeping. See the arrow, you can see it over the figure. Enabling the ready for data, after that placing the valid data over the data bus, and then it is going to be enabling the data valid line. Both is going to be remaining in the high state for a meantime, so the destination unit accepts the data. After that, we are going to be saying like it is disabling the destination unit will disable the ready for data. Disabling the ready for data, it is shown through the falling edge of the pulse. And after that, it is going to be is going to be disabling the data valid line, which you can see the curve here and by the falling edge of the pulse there. And finally, it is going to be removing the valid data from the data bus, which means like invalidating the data from the data bus finally by the source. And coming to the next subtopic in asynchronous data transfer, we have something called asynchronous serial transfer. When the data is being transmitted, the data can be transmitted either in serial way or either in the parallel way. When we go with the serial kind of transmission, the data transmission between the source and the destination, it will be carried away in serial. Like the binary information will be transmitted over one single line, one bit, one after the other. That we will be saying it as an serial transmission. And we say like serial transmission is like slow kind of transmission. Why? Because the bits are like transmitted one after the other serially, and here it is going to be transmitted over one particular line, much wiring is not needed for the serial transmission. But another way of transmission is the parallel transmission, where we say like the data transfer between the source and destination will happen through an parallel transmission, where a number of bits can be transmitted simultaneously at the same time. Like let us assume it wants to send some 8-bit of data. 8-bit of binary data will be transmitted over 8-bit line bus. and simultaneously all bits will be transmitted. So we are going to be saying like it is a faster kind of transmission there. And here we are going to be saying like when we use parallel kind of transmission, here the wiring is more needed. Why? Because if we want to transmit all the bits at a time, more number of data lines we need for transmitting the data simultaneously. And here especially we are going to be studying about asynchronous serial transfer. As already we have told like it is asynchronous, we are going to be saying like both the registers of interface and the CPU are going to have their own private clocks. Then how will it recognize like the data is coming? Let us assume how will it identifies like the data is coming from source to the destination. How will it identifies the data is coming from the source? Let us see like when we go with how it will identify is nothing but here it is going to be using some respective pattern. What is that pattern is nothing but it is going to be using start and stop bits. While the data when it wants to transfer the data that is binary data, here it will add start bit at the starting position of the data. Usually that start bit will be the 0 bit, and it at the end of the data it will add stop bits. Usually the stop bit will be 1, and depending upon the organization it may have 1 stop bit or it may have 2 stop bits depending upon the requirement there. Let us see the diagram there. And here it represents asynchronous serial. This diagram represents asynchronous serial transfer. You can see like the start bit which is going to be represented by 0, and here in this example we have taken 8 character bits. That is nothing but each and every character is represented by 8 bits. So we are going to have 8 character bits, and here we are going to have stop bits. Stop bits are usually represented by 1. We can take either only 1 stop bit or we can take either 2 stop bits depending upon our organization. Usually when the data is not transmitted, the line will be remained in the ideal state, that is 1 state, and when it starts transmitting the data it will go to the 0 state, which indicates like it is the start bit, and following the start bit or the character bits which were transmitted there. And after that we are going to be saying like we may at the end it is going to end of the data is represented using the start and stop bits there. And let us go with one more subtopic there in asynchronous data transfer, that we will be saying it as an asynchronous communication interface. When we go with the asynchronous communication interface, here we have an block diagram that represents the asynchronous communication interface, where you are seeing the block diagram. You can see like there we have something called timing and control circuit, and then we have some respective registers like transmitter registers, control register, status register, receiver register, and then we have shift registers, we have transmitter control and clock, receiver control and clock, and then we have shift registers there. And here we have something called bus buffers also there. Actually, this particular asynchronous communication interface, it is connected to the CPU through the bidirectional data bus. Here, it will be connected to the CPU, and from here it will be connected to the I/O devices. Transmitting the data, it may be connected to the monitor or it may be connected to the printer. Receiving the data, from here it may be connected to the keyboard or it may be connected to the mouse here. And here let me explain like what does each and every register can hold kind of thing. And here the data is being transmitted using the bidirectional data bus from the CPU. The data gets and stored in the bus buffers there. And from bus buffers, you can see like the data may be transmitted to the transmitter register, from transmitter register to the shift register, or the data which is coming from the receiving unit, it may be coming to the shift register, and from shift register it will be moving to the receiver register, and from receiver register to the data will be stored into the bus buffers and to the registers inside the CPU. And here we have timing and control circuit. The different inputs for the timing and control are: CS represents chip select, like when it is enabled, this particular asynchronous interface will be in the working condition there. Register select, which register it is going to be selecting for transmitting the data, it depends upon the value of RS there, and what kind of operation it is going to be performing. Like whether it is performing and read operation, it will enable the read line, and if it is performing and write operation, it will enable the IO write line there. And here how exactly it is going to be knowing, like what kind of information it is transmitting into which register, it is going to be representing like what values we are going to be supplying for the inputs of timing and control. The table here represents like which register is used and what kind of operation is going to be done. Like when we go with the CS value is equal to 0 and RS value is not given any of the value, nothing operation is going to be done. The circuit, the interface is going to be remaining in the high impedance state, where we will say like it acts like an open circuit. It will not transmit any kind of data there. So when we want this particular asynchronous communication interface to be in working condition, we need to check like CS value should always be equal to 1. So you can see the second row where CS equal to 1 and RS equal to 0, it will perform an write operation into the transmitter register, in the sense like the data from the CPU registers, it will be transmitted to the transmitter register. In the same way, when the CS value is equal to 1 and RS value is equal to 1, it again performs the write operation, and it will put that writing the data into the control register there. And when CS value is equal to 1 and RS value equal to 0, it performs the reading operation from the receiver register. Why? Because receiver register holds the data which came from any of the input device there. And coming to the next one, CS value is equal to 1 and RS value is equal to 1. Again it performs an read operation over the information which is stored in status register there. Usually control information will be stored in control register, like what kind of operation it is performing, whether it is performing the read operation or the write operation, like information will be stored in the control register. When we come to the status register usually holds the status of the data transmission, like whether any errors had been occurred during the transmission, that kind of data will be stored in the status register. Even it will have the flag values, like whether the transmitter register is empty or the receiver register is full. That information also will be stored in the status register there. And let us now exactly go with the explanation of this asynchronous communication interface. Let us assume the data is being transmitted, and one important thing what you need to remember here is, when we go with the asynchronous communication interface, this interface will act both like an transmitter and receiver. It transmits the data to any of the output devices and it receives the data from any of the input devices. So here we are going to be saying like this asynchronous communication interface acts both as a transmitter and the receiver. Let us see how exactly it will transmit the data. If the data needs to be transmitted from CPU registers to the transmitter register,
it will come through the bidirectional data bus. The data gets stored in the bus buffers, and from there the data will come and store in the transmitter register. And here we will have the flags. That flags should be checked to know like the transmitter register is empty or not. If it is transmitting the data into the transmitter register, it should check the flag and should know like it is empty or not. If the data is already present in the transmitter register, it can't send new data into the transmitter register. So it needs to check the status flags there. If the transmitter register is empty only, then the CPU can send the data into the transmitter register. From transmitter register to the shift register, usually the data will be transmitted parallelly. I have already discussed about what is meant by serial transmission and what is meant by parallel transmission. Parallel transmission, where we can say like the data is, the number of bits were transmitted parallelly at the same time. Right? So, transmitter register transmits the bits parallelly into the shift register, and from shift register to the any of the output device, the data will be transmitted serially by adding start and stop bits there. Okay, why? Because the destination unit, it may be any of the output device, it should know like data is coming from the CPU. So, from the shift register, the data will be transmitted serially by adding start and stop bits. Like this, the data will be sent to the any of the output device like monitors or the printers. Now, let us see how exactly the data is going to be, the interface is going to be receiving the data from the interface and how it is sending to the CPU. From here, actually, we are going to be saying like, from any of the input device, it receives the data. When it receives the data from the input device and stores in the shift register, here actually the start and stop bits will be there. Why? Because it needs to identify like data is coming. So it receives the data serially with start and stop bits and stores the information in the shift register, and from there the data will be transmitted to the receiver register. When it transmits the data from shift register to the receiver register, it removes the start and stop bits and it will transmit the data parallelly to the receiver register there. And from receiver register, the data through the internal bus gets transmitted and it will get stored in the bus buffers, and from bus buffers through the bidirectional data bus, the information will be sent and stored in the CPU registers there. So here you can see receives the data serially with start and stop bits stored in the shift register, and data is transmitted parallelly by removing start and stop bits to the receiver register through the internal bus. Through the bus buffers, it will get stored into the CPU registers. But here, before receiving the data, the CPU needs to check the status flags. As already I have told, when it was transmitting the data into the transmitter register, it needs to check like transmitter register is empty or not. If it is empty, it will transmit the data into the transmitter register and it will clear the flag, indicating like now the transmitter register is full. It can't send new data into the transmitter register, and from transmitter register to the shift register and to the output device there. In the same way, when it receives the data to the shift register and transmits the data from shift register to the receiver register, parallelly it needs to see like the CPU will be checking the status of the receiver register. When the receiver register is full, CPU will think like the new data had came from any of the input device which is present in the receiver register, and it will transmit the data to the bus buffers and to the bidirectional data bus. This is the explanation of the asynchronous asynchronous communication interface, like you can see like it is going to be acting both as a transmitter and the receiver, and you can say like the particular status register is going to be storing the bits, as I have told, flag bits it is going to be storing and recording some errors if anything happened during the transmission. That all also is going to be stored in the status register. And as I have told, for the timing and control, we have something called register select. We have read and write control lines, which will be used to activate any one of them while performing either the read operation or the write operation. And as I have told, how it works as an receiver and how it works as a transmitter. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.